In this video, I will be talking about the radiative zone of the sun. So if you look inside this picture, this is a core here. The radiative zone starts from this point up to here. So this is about 25% of the size of the sun, and this is about 70% of the sun. So the radiative zone extends from 25% to 70% of the radius. If you look the temperature of the temperature at this point is 8 million Kelvin, and at this point the temperature is 2 million Kelvin. At this point it is 8 million Kelvin, and at this point it is 2 million Kelvin. So the temperature has also a huge difference over the radiative zone. It goes from 8 million to 2 million Kelvin. Now if you look the density at this point, which is the inner of the radiative zone, at this point the density is about 20 gram per cubic centimeter, and at this point the density is about 0.2 gram per cubic centimeter. About 20 gram per cubic centimeter at the inner most layer of the radiative zone. And 0.2 gram per cubic centimeter at the top of the radiative zone. Now we'll talk about how the energy is carried out in the radiative zone. So if you look the radiative zone, it is quite dense. It is about 20 gram per cubic centimeter. So the photon or the energy which is released or produced in the core first passes through the radiative zone, and to reach the photon from this point to this point, it almost takes million years just to cover the distance. And why it is taking so long? Why does it take a million years to travel the radiative zone? The reason is it is quite dense. So let me draw a picture here to describe about it. So how does it work? Let's say this is the core. This is the core and this is the radiative zone. So now let's say this is the photon. When this photon is released, it travels from the core to the surface. Now as this photon travels, it encounters another material, or the hydrogen atom or the helium atom, the helium, and it hits the another atom. When it hits it, it can move in any direction. It might move into this direction, and then again when it comes to another when it hits another atom, it might move in some other direction, and then it keeps bumping up with the other atoms. And this path or this motion is called the random walk.